And it's time for Catalog and Cocktails. Live from Austin, Data.World is our sponsor. Hey, everyone. I'm Tim Gasper, VP of Product over at Data.World, longtime data nerd, longtime product guy, and excited to have our honest, no BS, non salesy conversation about data with you, joined by co host Juan.
Hey, Tim, I'm Juan Cicada, principal scientist here at Data.World, and Wednesday, middle of the week, towards the end of the day. I'm actually on the East Coast today, so it is 5 o'clock. It now is almost the end of my day. And today is such an exciting day because we get to talk to the one and only Bob Muglia, the former CEO of Snowflake, who's had an amazing career, and we have the privilege and honor to pick your brain here today. Bob, how are you doing?
Good. It's good to see you guys. It's great to be here in this talk.
So awesome. Excited to have you.
So let's kick it off with our tell and toast. So what are we drinking and what are we toasting for today, Bob?
Well, I'm drinking my usual. It's 2 o'clock here in Seattle, so I haven't broken anything else out. So I'm drinking my usual Diet Coke in the afternoon. And hey, why not today? Let's toast knowledge graph, shall we? Let's have the knowledge graph conversation.
Oh, yeah, I love this one. Tim, what are you drinking today?
I am trying something new. I've got some blood orange cordial, and so I made a cocktail called a Rhyme or Reason. It's blood orange, rye whiskey, lime, and a little bit of orgeat, and it's pretty tasty.
Wow. Well, I'm actually in Atlanta this week, and my apartment here, we don't have a big bar like in my other house, so I only have is a vodka tamarindo, which I brought from Mexico, and I have some nice Aha sparkling water. I love these now. So that's my mix today, which is actually really refreshing. And I'm with you, Bob. We're going to be so excited to talk about knowledge graphs and knowledge. So let's cheers to that. Cheers for, hey, we have this, our summit is next week, and it's all about knowledge first and knowledge superheroes. So toast to knowledge.
Cheers to knowledge.
So we got our funny warm-up question today, which is, you were the first product manager for SQL Server. So what's your favorite movie sequel?
Boy, I know of no connection between those two things whatsoever. And in general, movies, the sequels are generally really awful. I like the Lord of the Rings trilogy. Can I count the Two Towers as the sequel? Or another good one. I thought about this a little more, and it's a little bit violent perhaps, but Kill Bill 2 was better than Kill Bill. That's for sure. That's for sure. So
that's an interesting
I like
opinion.
Tarantino is always fun anyway. It's always a lot of fun.
Nice.
How about you, Tim?
That's a hard question. I'm kind of with you, Bob. Usually the sequels are worse. If I had to pick one, maybe Terminator 2, because I thought the better special effects and the bad guy was really cool there. I like it when Arnold is the good guy. So that was a good one.
That was a good one.
I'm a Die Hard fan, and I guess it's a sequel to trilogy. Well, there's now many of them. I think Die Hard 4 or 5, that's not really bad, but 2 and 3 I like. So it's my favorite Christmas movie, number 1. But anyways, all right, let's. I'm just so excited. Let's get into this whole our discussion here. So, all right, Bob, honest, no BS. Lately, we've been starting to finally hear more about semantic layers, knowledge graphs. Why now?
Well, because I think the industry is reaching a point where the challenges that customers are starting to have are exposing problems that today's data platforms don't fully solve. And if you look where we're heading, where everybody is moving towards, and what everybody is doing is focusing on building data applications. And that's really, I think if you look at where predictive analytics are going, it's about building systems that eventually become part of they're part of the modern data stack, but they become part of the customer's, ultimately their operational system, to actually do predictions, to do predictions based on data, and to take actions autonomously, essentially. I mean, that's essentially what they need to do, is autonomously take action. And the platforms were really, really in the early stages of that, and people are trying to build a set of data applications. And one of the kinds of applications, and this is the space that you guys are in, is governance. And I'll just be the first to say governance is a data app, and it's the only way that I can possibly think about it as a data app, that essentially is built on top of the modern data stack platform. It's probably worth taking a second to talk about the modern data stack before we go into some of these other things.
Let's do this.
Because I think that's the foundation, really. And we've if you went back, I put the creation of the modern data stack to 2012 when AWS bought Par Excel and introduced Redshift. And then in the years or two that followed, we had an initial stack of applications, predominantly SaaS applications, being connected to Redshift, through ELT's tools. I think Fivetran has made a big difference in this in terms of demonstrating a new kind of model in terms of a data pipeline and creating an operational system that then gets transformed within the warehouse. I mean, before Fivetran, and Fivetran really did change this. I mean, I was there, I watched it happen, and had the conversations with the architects back in 2014 with George Taylor and Mel, who was George's architect there, about the idea of building an idempotent pipeline and building an operation, essentially copying all the data from the operational system and putting it in the data warehouse and doing the transforms in the data warehouse. And that was new back then I'm talking about 2014, 2015 now. And that was new back then because, in the past, the data warehouses were so damn expensive, people couldn't do that. And that's why ETL tools worked differently in the past. Well, with Redshift out there, super cheap, you could start to do that in the data warehouse. And then Snowflake came along and because it was built to take advantage of cloud architecture, particularly the separation of storage and compute. I mean, it really unlocked the limitations for customers and allowed people to build highly scalable systems. And that design pattern of that compute and storage separation is now being copied essentially by all of the major platforms. And so we sort of are in a situation today where we have 5 major platforms that are all converging on what I would call similar solutions. I mean, the details are different in each case, but the solution set that's being built by AWS, Microsoft, Google, Snowflake, and Databricks. I mean, those are the 5 platforms that I see emerging as service platforms that are viable, are targets for people, with the modern data stack. The solution sets that can be built on all of them are quite similar. Now, you have biases to preferences. I will always be biased to Snowflake. I'll be the first to say that. I'll always be biased to Snowflake. I helped design the thing, but that doesn't say the other ones you can't. And people are solving problems very effectively on these other solutions too. And we're now in a situation where we have literally thousands of customers having successfully deployed that. And they're saying, okay, great, we're doing this. We're starting to do predictive analytics. Maybe we use Databricks for this. Maybe we use the native tools of the platform. We're seeing that now. Every one of these platforms has their own predictive analytics tools that are part of it. And of course, Databricks has a data warehouse that they're now touting. We can do the whole lakehouse discussion today if you want to take 5 minutes on that too. They've all are converging to something which is a very viable thing. And people are wanting to build data apps, but also to the point, people are wanting to govern these systems, and they've now gotten in a situation where all their data is together in one place inside their data lake / warehouse, and that's great, and it allows them to solve a lot of problems. But it really brings to the need for governance and determining who has appropriate access to that data, and the problems associated with governance are very much a superset of the problems that you need for a data application. I mean, to me, a data app needs to have the properties of the modern data stack. My definition, by the way, of the modern data stack is that it is delivered as a software. It is analytics, data analytics delivered as a software service that leverages the public cloud for scale and low cost. And its SQL is used for data modeling. So I use those 3 criteria to define what is a modern data stack. And again, I see these 5 platforms, AWS, BigQuery, Snowflake, Databricks, and then Microsoft Synapse being instantiations of that platform.
And Bob,
And
just for
all of these,
clarity, when you say analytics, you mean like the use case. The use case of the stack is for
right.
analytical purposes.
It's a platform. All of this is a platform for people to build solutions.
Mhm.
And ultimately, I draw this picture actually as a circle because you have, the main application, the operational system which is what the people use. And to me, these are really people applications, right? If you think about Salesforce or NetSuite or Zendesk, or even email is an example of or Slack is another really good one, is a people application. They're designed to be interacted by people, and they don't do anything pretty much unless somebody does something to them. And that is being used as a source of data that is pipelined into these data lake data warehouses, these modern cloud data warehouses that today have this analytics stack built on top of it. Typically Python is the primary language that people are using for that, and people are programming with a data frame, and that style of programming is pretty well established. And then we're now seeing reverse ETL tools coming out to actually take data, and insights from that modern data platform and put it back into the people applications. And that's really about data apps finding and doing things autonomously, and then invoking different actions elsewhere, sending an email, posting a Slack message, taking some kind of action to affect a customer, whatever makes sense. So, if you look at this problem, if you look at all of this, you say, okay, what's the problem that people are having? This gets back to your question. It's a long answer, but the beginning of the question, which is that governance is where people are struggling. And governance inherits all of the challenges of a data app. It should be a service. It should be something that you don't have to run yourself. It should leverage the modern data stack and integrate into the modern data stack, and certainly scale like the modern data stack does. And like data apps, it needs to be able to determine when data changes and take some kind of action autonomously from that. But the additional requirement that governance has that makes it so problematic is that you're dealing with metadata now about the data, and you potentially have millions of metadata elements in a large enterprise organization. And if you take a look at the combinations of relationships between them, you have almost an infinite number of combinations between them. And the kinds of analytic queries people want to run for governance requires effectively joins between those relationships, large numbers of those relationships, and SQL databases just can't handle it. They don't support dozens and dozens of joins or hundreds of joins effectively, because they use algorithms that are based on binary joins that go back 40 years, 40 years to 1970s, 1980s. They all use the same thing: DB2, Oracle, SQL Server, Redshift, Snowflake, BigQuery, you name it. They all use a similar set of algorithms that have been developed essentially over a 40-year period, and they just don't scale to that. And that's why people are looking at graph solutions as a data model for metadata. And that's fine. That's fine. It is sort of a graph, but I'm going to argue that the problem really requires a relational approach, because when you look at at databases, and I go back, I did a little bit of programming in Codicil in the 1970s. I did a fair amount of programming in hierarchical and networking databases in the 70s and early 80s. They were awful in a number of ways, but they're very powerful too. And even today's document databases have navigational attributes to them. And there's nothing wrong with navigational structures where you have hard-coded links in databases if your design patterns are similar. And if you're building an operational system where people do the same thing every day, they're putting in an airline transaction or something, a navigational database can make a lot of sense there because the design pattern is consistent and you know what the links are between the different nodes. But now you move into a world where the challenge is you have entities essentially that are we call it a node, call it an entity, with relationships. You can call those edges or relationships. It's a very similar concept, essentially the same concept, whether you want to think about it in a graph way or a relational way. And you now have millions of those, and you have to be able to work with them. And frankly, there is not a product on the market today that's generally available that is a database that supports that effectively. And that's where I think relational knowledge graphs are the answer. And that's why I think it's so interesting. And that's
I want to. This is brilliant conversation going on, which I'm going to go myself and repeat and listen again. But I want to kind of summarize some stuff we talked. And I know Sarah is here's asking the chat the 3 criteria for the modern data stack. So one, we are just delivering analytics on SaaS, leverages a public cloud, and SQL is being used for data modeling. Those are the 3 things that you talked about.
Yeah, the 3 things are software service, leverages the public cloud for scale and cost, right? Because that's the thing, is the public cloud's so much cheaper, plus it scales like nothing else does. And then SQL data modeling, yeah.
Okay. And then we started this conversation kind of on like why knowledge, and I love how we got into data apps. We're talking about governance as being your first step. And I think we've had this conversation before, right? I think your first application on a knowledge graph is of your metadata manager. Your data catalog is probably your first application on your data catalog. Would you agree on that?
Yeah, you start with the catalog. You absolutely start with the catalog. And then from that, you model it and you build a data model from that.
So this is something that we always talk about, right? The kind of the crawl, walk, and run, let's not boil the ocean type of thing. One of the stuff that I really like that you just said, or I'm kind of rephrasing it in my words, is that there are these known versus unknown use cases, right? So if they're known use cases, you know that they're going to be transactional, they're repeated and stuff. And kind of that's why it's fine if you're just going to be building things on your like traditional kind of structured relational databases. But it's when you start thinking about so many different entities and so many possible relationships, and then those use cases are known, but they're going to be so much more than unknown. If you even think about it from a metadata perspective, all this metadata, all this stuff is connected, that you're going to want to start asking the obvious, like, how many tables do I have? How many databases? But then you're going to start asking, like, well, what is the most important stored procedure that is being used that is not being governed or stuff? And then you're doing some sort of graph analytics type of stuff that now you're starting to ask questions that you didn't even think you could ask. And I think when you're starting to realize that you're going more into those unknown use cases, that's where having the knowledge and knowledge graphs, or I get the point that we want to be thinking also kind of from a SQL perspective, we were talking about a relational knowledge graph, but in general, thinking about knowledge is where you want to go if you're dealing with a lot of the unknowns. That's kind of a takeaway I'm having here about this. What do you think about that?
Well, I think that is an appropriate path for people to take. Okay. And it's an imperative for it. I think there's, generally speaking, an incredible amount of utility to building a business ontology and being able to manage a business through terms that are consistent with the business versus esoterica that's in the programs that runs. The complexity, I mean, let me back up a second, which is so my whole job in life has been essentially to take infrastructure that is complicated and very difficult for people to use and simplify it to the point where it can be deployed and used by as many people as possible. And I learned this at Microsoft, right? I mean, this was where I was trained on this at Microsoft, and that's kind of what Microsoft does in a way. Certainly did. I don't want to comment now, but I think it's also true today. But it takes, like, SQL Server wasn't the first relational database on the market. And it wasn't by any means the most broadly used or anything when Microsoft started using it. But when we took over our own ability to development on it, and we were able to bring it to many places, particularly small and medium-sized businesses that had never been touched by these systems. Remember, go back to 1992. Small businesses used pencil and paper. Okay, that's how they did business by and large, and that's not the typical case today. And they've been replaced by systems that were originally PCs and servers, and are now SaaS applications that are delivering equivalent and superior now services. But the idea of taking something that is very hard to use and making it broadly generalized is something that I think is very important. And right now we're at a point where the modern data stack in SQL, particularly when combined with the current state of the art, which I think is pretty primitive, but the current state of the art of machine learning and data and advanced analytics, people can do an awful lot with that. I mean, there's a lot of power in that. It breaks down, however, if your challenge is if you're trying to work with a data model that has a lot of separate entities that need to be joined together in some ways. And that's where people tend to look towards graph-based solutions. There are domains like the chemical, there's sets of domains where that kind of a model is more inherent and appropriate than a traditional SQL data model is. The other thing to realize about SQL is, while SQL is great, and Lord knows SQL has treated me as well as just about anybody on the planet, it's not God's gift to languages. I mean, it's not the last language that will ever be used. And it's not going to go away anytime soon. I'm not proposing that. In fact, I think, we're seeing the heyday of SQL currently today, but its limitations are also becoming clear. I mean, its limitations, the semantics are incomplete. And there were some things that were just done wrong, like the handling of nulls, which is just wrong.
This is a quick call out. I mean, I've been working with Professor Leonid Lipkin, and have a PhD student at Edinburgh, where we've been doing this big survey.
Have him on. It's the funniest. He's hysterical. He's got some of his comments.
I mean, luckily, I get the chance to talk to Leonid every week, and we're going to be releasing the results of our survey soon. But I feel like
so you should have him on this podcast. He would be a good one for this podcast. So.
All right.
That's a good idea.
But Tim, I know we wanted to get this. Let's keep going on SQL. Tim, you had some stuff that we're
so Bob, you mentioned that SQL is sort of the lingua franca right now in terms of a lot of things, but data modeling kind of included. And then you've got the rise of things like DBT. Like, why do you think that so much of the gravity around data modeling has centered around SQL? And what trends are you seeing there that you're worried about and that you're excited about?
Well, I'm excited that the trend has moved to SQL. I'll start by saying that I'm excited, and I actually think data modeling can be done effectively in SQL. Okay, I'll say that you can, and I think for straightforward data modeling for SQL databases, SQL is a great way to do it, and in fact, it is the way you do it. I had this conversation at one point with Christian Kleinerman, who is he runs product at Snowflake, and we were talking about modeling, and I am a big fan of the work that Lloyd Tabb did with LookML, and we adopted at Snowflake Looker very early, and we wound up using it as our initial BI tool. I never loved the UI of Looker, but I thought LookML was great, and and we used it a lot. But what we wound up discovering, and what bothered me, was that we were using it inside Snowflake, for our data modeling early on. And I'm like, this is wrong. I mean, we're doing it. I know why we're doing it, but this does not belong in a BI tool. This belongs earlier in the life cycle. It needs to go into the core database, and we need to have a platform. I'm a platform guy. We need to have a platform for being able to run any tools on it, and we need to be able to use Tableau. And in particular, I was like, dang it, we need to bring Tableau into Snowflake, because a lot of our customers use Tableau, and I always want to use what our customers are using. And most of our big customers you went and you said, what kind of BI tools you use? And they said, well, tell me which ones are out there, and I use them all. And so we wanted to have that support. And so you need to be able to do data modeling someplace else. And I remember talking to Christian because there's some very beautiful attributes of LookML. And Christian looked at me and said, Bob, the future of data modeling is SQL. And this is, and you can do what you need to do, and that's where we need to go. And it was about that same time that Tristan was really beginning to come out with, there were the early versions of DBT. This was Fishtown Analytics. And we saw some of the early versions of it. And, now it's been great to see the popularity of that being established. And essentially it's a straightforward thing, right? It takes a set of SQL statements and it chains them together, basically, in a way that allows you to do the tasks you need to do data modeling. It does a good job.
So where will the semantic layer live? Is that part of the storage in the snowflakes? Its own thing? The DBTs, the ETLs,
the semantic layer has to live above that. It has to live above that because the SQL database, it has the ability to model data. It does not have the ability to model business, okay? And if you want to have a semantic layer, you need to model business. And in order to do that, you need to be able to I sort of think, what are the sort of things that are required for governance. I mean, what are they? It's kind of interesting. Let me just the requirements, I think, first begin with the fact that you start with the data app requirements, and then you need this massive number of entities modeled. And again, it's how do you build something? How do you build a platform now? What is required for a platform that would be a semantic layer? And there isn't one out there. I mean, it's just a fact. I mean, there just is not one that you can go look to and say, I can use this product, or I can use this product, or I can use that product. And I guess the things that I see is this need to not only support the characteristics of a database that supports a massive number of entities and the relationships between them, so that rules out SQL databases, right? But that also embeds business logic into the database entities, and that's really required to understand the semantics. I mean, that's if you think about a semantic model, that's the other part of semantics, is the business logic.
I would say it's the ontology, the way how you're modeling the business, modeling the knowledge, and then it's the connection of that to the actual data wherever it is.
Right. And then that
are mappings, rules, transforms, however you want to go call it, queries.
What you're really describing. Okay, let's separate this one for a second. So you've got the modern data stack, which is modeling data, and we have standardized relational models that are being built, SQL models that are being built on top as a part of that. That data model needs to get reflected into the semantic model. But it's probably not, at least for now, it's probably not defined in the semantic model. Maybe eventually it gets defined in the semantic model and pushed down into the data layer. That may happen someday, but right now it's not happening for sure, because the data layer is being defined, and maybe you can just treat this as a source of information. And so you've got the semantic model that needs to understand the data model, but then it needs to understand a lot more than that too. It needs to understand the relationships between the data first and foremost. That's what turns it into an ontology. And then it also needs to understand the business semantics around that, how you calculate, price, how you calculate earnings, how you calculate this. And so you now have business entities that are terms that are understandable by business analysts. And those will map underneath to the data structures that ultimately will come out of the modern data stack. Now, some things, a lot of that's great because you can use that to, for example, define business metrics. And this is kind of where Tristan's starting to head with DBT. If you read his latest blog on this, he's focusing on metrics. And, I'm trying to, I've been thinking about this, and I don't know, but what the hell is a business metric really? It's an interesting question, right? What is a metric? And what's a metric? You tell me. You guys tell me.
Last week I was at Data Council AI in Austin, and I was having good conversation with Ben Stansel, and because we've had this conversation with him, right? So I loved how he described it. Was you give me a list of things. Those things should be those things should be elements of my ontology, the business concept. Give me the list of customers, a list of suppliers, a list of users, right? And then there is a calculation, some calculation, and that's your metric. That what is the revenue? What is the active days, or like some math that is occurring, and that math that is occurring occurs over those list of things.
Let me give you a shorter definition. Let me try a shorter definition. An entity is a function applied to the relation. A metric is a function applied to the relationship between business entities, between entities. And it's really about the fact that you have, I have a fact table, and then I've got a dimension. This is, if you think about it, I've got a fact table and I have a dimension table, right? So you have a relationship between those two, and it's that, and you're aggregating that relationship typically. And then, we may say it's an average function or whatever, a median function you're applying to it. And it's about the relationship between things. And if you think about these things, and historically people have thought about these things in a multidimensional way. Now, if you start to just think about them pure relational, it takes, it's n dimensions basically, because everything can relate to everything else.
Okay, this is a big aha moment. It is 5:29. I'm just getting the 29-minute mark, what you just said here. A metric is a function applied to the relationships between business entities. And
between
if we, right,
usually
entities, right? So if we split this up, we say, well, first of all, the function is what I would meant like some calculation, but think about it. Now, metric is a function applied to relationship between business entities. Now, if we go from the other way around, is give me the list of business entities, your things, the relationships between them. So if I draw them on the whiteboard, the business entities are the bubbles.
Don't try to do that in Snowflake; it won't work.
Well, but I mean, let's think about it.
See what I'm saying? You can't do that in a SQL database. The question,
fair point. Again, that's why we're thinking about graphs here, right? Give me business entities which are bubbles on the whiteboard. The relationships are the lines between them, what makes it into a graph, right? So that's my ontology. So relationships between business entities, and then the metric is some function, a math, a calculation over that stuff. I love how we've been able to get this very concise, crisp. Exercises that I've gone through is I tell people, let's just draw it on the whiteboard. And then when I tell people, what is the problem you're trying to go solve? And they literally will draw a big bubble around it. Well, I'm trying to understand the relationships between this thing over here. And then that's like, yeah, that's your metric because you're trying to figure out what is the flow of things going in and out and so forth.
And of course, it can be more complicated than just two entities because you can have these aggregates can be cumulative, right?
Things so you layer on top of each other.
You layer on top of it. And I think that the reality of this is, it come back to what do you need? And I mean, I will say I start this thing from a perspective, and I will admit this, that my sort of journey in this path to knowledge graphs, let me just say, I'll go back to 84, I think it was 84, when I was working and I was building a network database. I was working on a system that was on the network database on an IBM PC. It was called DB Vista, but it was it was very, very sophisticated database. It was not relational at all. It was purely networking. And we were looking at some of the different kinds of problems that you'd need to solve back then. And I had a boss who I'm still very good friends with, who was talking about the ideas of modeling. And this was the time when modeling was totally in, and everybody was focused on building pretty pictures of models. And they actually were model generators. The company Inrix, which is still around building these modeling systems, they were around back in the early 80s. It used to generate COBOL code. Okay, you build a model. I don't think people remember this. They build a model and you talk about the relationships between the different business entities and things, and you generate COBOL code, which ran. Of course, it was unmaintainable. It didn't work. It was a total disaster. It was a complete non-starter. But this idea of building business models and then having those models be executable, to me, that's always been the holy grail. And that's the promise of knowledge graphs, right? That's the promise. Yeah. But the thing is, the question is, we start with this much messier state of current applications because, application logic is by definition split between the database and the application. Frequently, the database is just if you just CRUD, you could do CRUD reads and writes out of a database. But a lot of times, unless it's a SQL database, there might be a lot of logic inside that SQL database, particularly if there's stored procedures there. And those things have not gone away, by the way. They're still around in every regard. And so people start with this fairly messy infrastructure to build applications. And I think there's a promise to dramatically simplify that over time. But this has to be driven by a business requirement, something that you can't do effectively today. And the thing that you can't do effectively today is manage massive numbers of entities and do joins between them. And that's the problem that the platform has to solve. And the reason why I think governance is a chocolate mess right now. I'll just describe it as a chocolate mess. I can list like 12, there's like 30 different vendors in this space. They're all over. You guys are one of them. Data World's one of them. There's all these vendors. They all do pieces and parts of the thing. They don't really work together. And if you're a poor customer trying to make sense out of this, good luck. And I think the challenge and the reason why we're in this state of somewhat cacophony is because there is no common platform to build a metadata governance solution for the modern data stack. And the reason there's no platform is that the requirements of that platform are not satisfied by any database that's currently on the market. And and until we see a database that does that, which I think will be a relational knowledge graph, then we'll continue to see confusion. But I think it'll sort out in the next few years, because I think we will see that relational knowledge graph, and I think this will start to sort out.
That's interesting. And so obviously you're talking about how the database may play a big factor here, that technology.
I'm a
I'm
database
kind of
guy. What do you
curious.
think I would say? I've been building databases my whole life. What do you think? Everything was a database to me.
It has to do with databases. That's part of the answer. One question, just to zoom out a little bit. So you're talking about governance. You're talking about this sort of mess that you're trying to deal with, and then add on top of that mess some additional chocolate mess of governance on top. Like how do you envision catalog and governance helping with the semantic layer? Like, how are these two things actually going to come together?
Eventually, they become the core, right? I mean, they become the core of the knowledge graph. I mean, you guys are heading in that direction, and it's certainly part of where you're focused. But the catalog, in a sense, is at the simplest room. There's a raw catalog of data sources, right? Which is an uncultivated raw catalog of just a list, and that's a pretty straightforward data structure, actually. Maybe it's hierarchy. It looks a lot like a table. Maybe there's some hierarchy in there. But the question now is, when you take that raw sources of data, and you're dealing with tens of thousands and thousands of data sources in these very large corporations, you will wind up, when you get all that together, each one of those has hundreds, thousands of tables. You get millions of entities out of it. I mean, it's big. And it's so big that it's almost I mean, certainly for the biggest enterprises, it's not human scalable. I mean, the numbers are beyond what people can really deal with. So we now have to figure out how to compartmentalize that and begin to cultivate that raw set of data resources and turn it into something that makes sense to a business. And there's a lot that can be done, and a lot of the tools that are out there are using machine learning and things to begin to build business on top, to begin to build the basis of business structures from that. But we'll do more. I think we'll see more over time in improving that. And then there is the augmented side. I mean, this is the thing, is that an ontology has to be learned, because you have potentially millions of entities that you have to somehow bring in and correlate in some way. And then it has to also be augmented by human knowledge, because you can't look at this shit and understand what the business logic is. It's just impossible. The semantics are scattered everywhere. Ben wrote a good paper on this recently, where he talked about the semantics being scattered all over the place. And just even finding them is tough. And the opportunity with the knowledge graph is those business semantics can all be encapsulated in one place, hopefully in a way that humans can understand it. And by humans, I mean business analyst type people, not programmers.
Yeah, no, this is a really important aspect here. You're saying is I think we always live in this world that everything we want to be automated. And yeah, we can't start from scratch and then go expect talking to people and build this completely manual. You want to be able to go learn this stuff as much as you can, but we also need to acknowledge that it's like the knowledge comes from our brains, our people. We have context, so we need to have this. I mean, we always talk about human in the loop, and I always
question, where is that knowledge stored today in business? Where is it today?
So it's stored in schemas. It's stored in a bunch of queries, in reports, in
Python
code. It's stored in
procedures. How much of it's still in Excel?
In Excel, in Access databases. Unfortunately, I get to see those things. It's in application logic. Right. It's in the quality, right? People are, this thing came out this other way. It's literally all over the place. Right. And the thing is that, and there's just so many bodies that are buried all over the place, and people retired, and it's somewhere in Florida.
This is the thing where the business logic becomes lost in history, because the person who wrote it is no longer at the company. And then, a lot of it no longer makes sense too, right? A lot of it is ancient, having to do with failed programs and things like that somebody put in there, and nobody knows whether you can take it out or not, right? These are the challenges. And part of it is what you want to do. I always said when people move to Snowflake, I always told them, use your the tool that you use to move data, like if you use Informatica or Talent, whatever, use that continue using that tool and just redirect it to Snowflake. Get your data on Snowflake, begin to build off of there, and then think about how you clean up the other stuff. The challenge with the older tools is they lack all the data, right? Because you're selecting data and you're moving fields and all the field mapping and all that kind of stuff versus just sucking it all up and putting it in the data warehouse where you have all the data now and you can do whatever you want with it, which is the more modern way of handling it. But people don't do these things very quickly. It takes a long time. And that's why I say you don't go from, great, the knowledge graph is the holy grail of data modeling and executable models. Woo-hoo, I look forward to that day. We're talking 2030, 2035, that kind of period, which is not unreasonable, by the way. I mean, I've been doing this thing for 40 years. It's not unreasonable to think that this will take, 8, 10 years to happen. But in the interim, there are business problems that are real that have to get solved, and the current generation of platforms are inadequate to solve it. And predominantly the issues that are most acute for many companies. I mean, there's other business issues that perhaps companies have that are quite acute, but one that is broadly applicable across pretty much everyone that's implemented the modern data stack is governance. And part of the reason why we have some of the chocolate mess associated with the current thing, it all comes down to the fact that there's no standardized platform to build this stuff on.
All right. Well, I want to start shifting into our lightning round section here, because I know we keep talking. There's so much stuff. So, all right, let's move to our lightning round, which again, thanks to Data.World who sponsors us. So I'll go with question number 1. Are semantic graph skills going to be required for enterprises to build out their knowledge graphs?
Are semantic what skills?
Just semantic skills, semantic graph, like just knowing more about graphs and semantic skills.
I think this is one of the skill challenges, to me, is by far the biggest concern I have in terms of this transition. I think we move from a world where business logic is defined procedurally in code, in languages like Python, to declarative business logic that is essentially a set of rules that are attached to the entities and that then are triggered in sequence based on other changes to data and other rules that have fired, so that they can actually be recursive and react to whatever happens and respond in a way that is completely coherent with the logic that you've defined. And this goes back to the original work that COD did back in the 1970s, where COD defined both what was it? Trying the word, blanking on
relational calculus, relational algebra.
He defined both calculus. He defined a relational calculus, which was purely declarative, a purely declarative relational calculus that you could work with, and that's analogous to the procedural code.
Yeah. So, I mean, I think we have to go start getting people and teaching them again. Logic
training is logic is back, going to be back. I think
logic is back, baby. Think about AI. No more AI, which is just machine learning. It is going back to GoFi, good old fashioned AI with rules and stuff. Tim, go to the second one. Your turn.
Yeah. So, hey, Bob, I want to ask you for the second question here, kind of a prediction question. And I'm actually going to put a little bit of a timeline on it. So let's say in the next 10 years, will most enterprises build out an enterprise knowledge graph or enterprise knowledge graphs in the next 10 years?
Absolutely. In 10 years, absolutely.
Right.
5 years, I'm not so sure. 5 years, you might be a little bit the question.
5 years, a little edgier.
5 years, I think it'll be happening. I don't think will have gotten to the word most right now.
Okay.
Have most? How many would you have not? I wouldn't even say most have gone onto the modern data stack yet.
Yeah, I would say not most.
Yeah, I guess the question is how many, and they're already starting their journey by using one of the Snowflake or Databricks. Like that's the first step, right?
Well, and that brings up an interesting question. Like, is the modern data stack a requirement to building your enterprise knowledge graph?
Effectively. I'm not going to tell you it's the only way to do it, because you can do it by hand. There are other approaches that people have done, but you better be out in Silicon Valley and have an awful lot of money to do it. I mean, any rational company that would probably adopt the services that are purchasable by one of these vendors versus trying. You can hand roll this stuff, and if you're Netflix or, one of these guys, you can succeed at some of that stuff. And even those guys are turning to the modern data stack. I mean, even people who have invested massively in alternative solutions are using the modern data stack because it works and not cheap. I'm not telling you that this stuff is cheap, but it's very cost effective relative to the alternatives of DIY.
All right. Next question. Is the semantic layer going to happen as a byproduct of something else, or will it be deliberately built?
Both. I mean, it will be deliberately built, but I think it will be built in the context of governance. I think governance is the first application for the knowledge graph and the semantic layer.
Interesting. So governance is a key driver there.
I think so, because it's acute. I mean, it's acute. It's an acute problem that everybody has, and it's not being adequately solved.
I like that take. All right, fourth question for you here. Do you predict that ultimately there will be wide adoption of an open metadata standard?
Yes. I mean, at least for exchange of metadata. Metadata exchange is actually pretty simple. And what's the it's not the what's the standard? The Apache has a standard.
Atlas.
Atlas is not a terrible basis. I mean, I don't think that I think that it's a foundation that people can build upon. I mean, I don't know that it'll be the end by any means, though.
Excellent that you brought up Atlas. Before here, I was talking to Venkatesh, and he actually says hello, right? So I was talking about Apache Atlas with him. So
it's interesting. I think that look, having something that is adequate is often sufficient to build these interchanges. You don't have to have. In fact, you usually don't want every bell and whistle. You put all the damn bells and whistles, it doesn't work.
That's interesting. Yeah. Well, quick follow-up question to that. I know we're breaking our lightning rules a little bit here, but do you think that open metadata standards are going to be driven more by sort of the community and the consumer pull, or do you think some vendor is going to kind of win at the metadata game, quote unquote, and they'll have been, pushing a particular standard?
I don't know, because it's too early to know how it's going to work. I mean, I think this is the wild. I mean, this place is Wild West right now. It's not clear how it's going to emerge. It reminds me a lot of the data analytics world in 2013, 2014, where the clarity just wasn't there.
Yeah, the early landscape where you're like, it could go this way, it could go that way. There's a lot of possibilities here.
I mean, there's no dominant vendor that is obvious at the moment that would clearly dominate. There's well-established vendors that have been around for a while, and there's the big cloud guys, but nothing that's obvious that's going to become a single dominant thing.
All right. We're going to go to our next segment here. The new one is the mesh minute. We haven't talked about data mesh, so we're starting to go do this. I want to time it to a minute. I actually got here by my clock. 1 minute. You can rant, pontificate, whatever you want about data mesh. Ready? Go.
What's a blog without a talk about data? What's a discussion without data mesh? Mesh is really two things in my mind. It is a organizational model that describes how to structure data teams into domains and leverage that. And I think that those concepts are just basically right, fundamentally. Those are strong concepts. They've been around for a really long time. They've been applied to software development. They're being applied to data. They're appropriate, particularly for larger teams. Mesh sometimes tries to define implementation approaches that I don't think necessarily are the right approach. And I think it's important to separate an implementation of a data mesh from the organizational structure. And my opinion is the best products to implement data mesh are the modern data stack. And to use, certainly tools like Snowflake were designed to allow for data sharing and organizational structures like mesh proposes. So
perfectly on time.
That was good.
That was great.
Organization of mesh. I like the domain organization in mesh. I mean, I don't necessarily like the prescription for how to build streaming-based things that I'm not a big fan of.
There's a lot of things that are kind of tied together, but yeah, the domain-driven concept is it's not new, but it's now kind of reborn again, right?
It's actually, to me, the important concept of mesh. And I think it's incredibly important when we start talking about governance, okay? Because for large organizations, thinking about data domains and separating points of control, I agree totally with that. If you're a 100-person company, if you're a 3-person data team, that's pretty different, though.
All right. Well, Tim, take us away with your takeaways. Kick it off.
Yeah, sure. Well, first of all, I like the comment that you just made there that, like, governance and data mesh are important to each other, and that domains are a key concept there. I think that's resonates a lot with the way I think about things. I think it resonates pretty closely with Juan's perspective too. So it's good to hear that. And one of the reasons why I'm very excited about data mesh. Couple things I wrote down here. First of all is that we're reaching a point where a lot of the problems of old data stacks are being exposed. A lot of folks are moving to the modern data stack. We're seeing more and more of that. And a lot of the goals here are what you mentioned around building data apps, which ultimately are going to be, predictive analytics that become part of customer applications in order to take actions. And that governance happens to be one kind of data app. And you kind of mentioned that it's probably one of the ones that you implement early, or perhaps even at the start, and can be a foundation for more semantics, for more sort of data apps that you want to do in the future. And you went through some of the history around the modern data stack, which I think is very important and valuable, especially for folks who are a little bit newer to the data space, who maybe only know the modern data stack, and they don't even know like what was before. They're like, what, before Redshift? Like, Redshift is the legacy thing, right? And so obviously it's good to know, like, why are we here? Where have we come from? And what are some of the design patterns here? And you mentioned these 5 core sort of most popular platforms around the metadata stack, or the modern data stack, right? And those being sort of AWS, Microsoft, Google, Snowflake, and Databricks. And bigger companies and and smaller ones too are often using multiple of these, but these are sort of the ecosystems that are forming around these 5 key players to provide analytics, software as a service, public cloud, and ultimately SQL as a core component of this modern data stack. What about you, Juan?
All right. So I got three main things. One, governance is where people are struggling, right? We talked about your first knowledge graph should be your metadata, and governance is really that first data app. And you start with a catalog, and then you build up with your data model, right? That's what governance is going to go evolve to. So governance. Second, the semantic layer is about modeling the business. And the key phrase, the key takeaway here is metric is a function applied to the relationships between business entities. And the promise here of knowledge graphs is making these business models executable. So you start thinking about the semantic layer plus the catalog, like that's going to be the core right there. And these ontologies of semantic layer, these have to be learned, but they also need to be augmented by humans. And then finally, you said SQL is not God's gift to mankind, to everybody here, but it won't go away. It does have its limitations. We're learning more about them. A lot of data modeling can be done in SQL, but we're going to be seeing more. We're going to start thinking more about logic and knowledge representation and so forth. How did we do, Bob?
Great. No, I think those are all rational takeaways. I mean, I think that I see governance as the bridge between today's modern data stack and the future of knowledge graphs. And I think these two things are integrated, but they're also independent in the long run too. I mean, the knowledge graphs will be leveraged for the modern data stack for many years. Eventually, perhaps the knowledge graph will replace it. We can do everything, but we're at least 10 years away from that, maybe 15.
Well, I what you just said is just the music to my ears and kind of everything I have in my passion, because this has been like my academic and adult career the last 15 years has just been about semantics and knowledge graphs. So just finally seeing this here and having you, Bob, talking about this, it's like, okay, we're heading the right direction. So
it's coming. It's coming. It's early. I just can't stress how early. It's like SQL was in the early 80s. That's my comparison. I mean, and it'd be really maybe even the late 70s. I mean, it's really early in this journey.
Yeah.
SQL's been around for 40 years. 40. Okay.
A call out to people here is that if you're skeptical about this, all right, fine, you'll be a follower you won't be a leader because this is where we're going. So do you want to
Well,
be a
I
leader?
mean, look, I think the people just get on the modern data stack, they're taking the right step. I mean, people can do so much. I mean, they start with this, mess of a situation that they have. Really, I mean, where you go back, most companies that are not using the modern data stack are using Excel. Okay. and the state of the art is a finance analyst.
I think that's a hopeful message, Bob, that you're providing here, because I think sometimes people who are a little more cynical about the modern data stack might be like, it feels like it's the new generation of point-to-point solutions or things like that. But I get the spirit or the feeling that you're like, yeah, maybe there's going to be some missteps or things like that, but like this is the train to ride. This is the train that's going to take you towards the knowledge future. Welcome aboard.
You should, and she's one of those vendors, and I, they're all getting there, right? I mean, they're all actually improving and getting there. So,
all right, Bob. Final two questions. One, what's your advice about data, about life, whatever? Second, who should we invite next?
So, about data, I think I just said it right, really, which is get on the modern data stack. That's the thing I really would say to everyone. That is about data, certainly. And I guess life, I would say, try and chill out in today's world. I mean, sitting there watching the Ukrainians, the horrible things that are happening in the world today. We're, this is one of the, I grew up through the Cold War. I ducked and covered when I was a kid in elementary school. And, we're in a weird time right now. It's a weird time in the world. We're seeing, I think we may have a rough year. The year we're seeing super high inflation rates. I don't know whether we may head for a recession or not. It would not surprise me. So I think there's a rough time in the next year or two. Hopefully all these things straighten out and we all wind up in a better place as a result. I'm a big believer that technology is what moves the world forward and helps to make things better. I believe that somewhat naively. I know that for every step forward, there are backward steps. 2 steps forward, at least 1 step back, maybe 3 sometimes. And but I do believe that we're heading in the right direction. And by making data, one of the things I've been a huge believer in is that data, when believed and trusted, just cuts through and makes decisions so much easier. And I can tell you, there's so many times I would sit and we would have discussions on a business item and we would talk about it for 2 to 3 weeks, and you get to the end of it and you don't really know what to do, but so you make a decision. The difference between that and being able to say, what does the data say? And then look at that data and then decide how to respond to that. And it's just very real. And it's a major cultural change for companies. So the reason I say move to the modern data stack is to become data driven and have that become imbued within your culture. And then to begin to do, today's world, once you become data driven, you really want to apply predictive analytics to it, because that's when the magic happens. That's where you get superpowers and can see problems that were otherwise invisible, predict the future. I mean, do all these things with predictive analytics for real. And it's a superpower, and it makes making business decisions so much better. So that's why I just say focus and get to that today, become data driven, and then follow the path to data applications and ultimately to the future of ontologies and knowledge graphs.
All right. And quickly, who should we invite next?
Well, you haven't had Benoit on. That'd be a good one.
All right.
So
we will ask for that. Bob, this was amazing. Thank you so much for this conversation. I think so much stuff that we've gotten out of this, and being very hopeful about what the future is, and it's achievable for everybody. So next week we have Nong Lee, who's the CEO of Okera, and we'll be talking about the policies and data. So that's next week. Bob, thank you so much again. Thanks to Data World for supporting us all the time at Catalog and Cocktails. We get to do this every week. So cheers, Bob. Cheers, Tim.
Cheers.
Appreciate it. Cheers, Bob.
Take care.